All right, guys. Last class of the year. Breathe it in, treasure it, savor it. I know there's a buzz, right? Because the excitement in the air. All right. Honestly, I don't have much of my own for you today. I have just a few quick hitter reactions I'm just going to want to highlight here of nitriles. The mechanisms for these are really, really convoluted, and even some of the steps really are not well worked out. So the thing with nitriles is, I hate to use the M word, but just memorizing these is probably the best option. So reactions of nitriles. The first thing that you can do with a nitrile, and remember, a nitrile is something that has a C-N triple bond, right? So let's say you had something like that. Right, there's a few different things you can do with them. The first thing that you can do is hydrolysis, and there's actually a couple of different hydrolysis reactions that you can do. You can hydrolyze nitriles either in acidic media or in basic media. So that means either in the presence of hydronium or in the presence of hydroxide. And they lead to very, very similar products with one important little difference, all right? So basically what's going to happen here is that your CN group is going to get transformed, all right? Now, when you hydrolyze it, it's going to be converted into a carboxyl group. So the C that was in the triple bond now becomes a carboxyl carbon. And if you remember, carboxyl groups are part of carboxylic acids. So if you do an acid hydrolysis of a nitrile, you're going to get a carboxylic acid. Same number of carbons, everything, the nitrogen goes away. This carbon gets turned into this group. All right? Now, for hydrolysis and base, it's very, very similar with one important option, or not option, feature, I guess you could say. All right, that's still going to become a carboxyl carbon. But since you have a basic atmosphere, if you have a basic atmosphere and you have a carboxylic acid, what do you think is going to happen to it? Carboxylic acid, what that acid's like to do, it's going to donate a proton if there's anything basic enough to accept it. Well, gee whiz, we've got a bunch of this nearby. So what actually happens is this doesn't produce a carboxylic acid, it produces a carboxylate ion. So one small difference, but important. So like if you wanted to move ahead and make an anhydride or something, you know, this would be a good intermediate step to make that carboxylate and then react it with something else. Okay. Any questions about that? Not much more to say about those reactions. It's pretty much straightforward. There's not really a lot of nuance to it. Not really anything in the way of exceptions or anything like that. It's pretty much a straight up hydrolysis. All right. Let me double check something real quick. Yeah. Okay. Nitriles can also react with with hydride sources. So you remember the strong and weak hydride sources we talked about before? Strong being something like lithium and aluminum hydride. Well, you can have the same basic setup that we've used in other situations, right? Strong, oops. Oh, I'm in a group chat on Messenger, so I'm gonna start getting 1,000 of these pings. All right, so you have the same basic setup, right? Strong hydride source followed up by water, right? And so if you remember, the purpose of a hydride source is to reduce a group, and that's exactly what we're doing here. We've got 3 bonds from carbon to nitrogen. If we're reducing that carbon, that means we're going to lower the number of bonds to nitrogen. If we're using a strong hydride source, that means it's going to be reduced all the way to an amine, to an NH2. So, if you do a strong hydride reduction of nitrile, you're going to get a primary amine. Now you can also do this with a weak reducing agent. So you could do this with dival-H. Now this is where, at least the first one seemed pretty intuitive. This one I'll just straight up tell you is not intuitive. So this one you definitely just have to commit to memory. All right. When you do a hydride reduction, a weak hydride reduction of the nitrile, you're going to get an aldehyde. Always. And this is a reduction, right? You know, 3 bonds to electronegative atoms of this carbon. Now it only has 2. It just so happens those 2 are to a completely different atom. So it looks a little weird, but that's what you get. Okay? Always get an aldehyde. All right, one other thing that you can do, and I'll just use this guy, draw another arrow. You can also react nitriles with strong organometallics. So this works with either Grignard or organolithiums. Doesn't do anything with organocuprates. So we use the Grignard reagent. All right, same setup. You got your organometallic. What this is going to do, this is going to serve as a source of an R group. And it's going to give you a ketone. That new R group becomes bonded to this carbon, which used to be part of your CN. Again, your N just kind of goes away. But you always get a ketone. All right. Are there any questions about reductions or, reductions or nitriles or hydrolysis of nitriles? Like I said, don't worry about the mechanism here, but this is another group of reactions you should add, I guess, to your reaction bank. And that is pretty much it. That's not it for organic chemistry, in a vacuum. I haven't taught you everything about organic, believe it or not. There's lots more out there. I know it's hard to believe, but one of the things I think I'm weak at is I go a little too slow. So I always end up with extra chapters that I wish I could have gone over. I know you're like, what the hell? Dude, this isn't enough stuff. I know, it's okay. But, you know, want you to understand it. So we are going to cut it off here. This is the end of chapter, whatever this is, 22. So this is our stopping point. All right. So we can use the time remaining however you want to. We can work, you know, homework problems if you had specific questions about those. Have I given you sapling for this chapter yet? I need to do that. You probably would appreciate the practice, right? Maybe not.
It's fresh memories.
What was I going to say? Oh yeah, update. If you guys weren't here the other day, remember I said, yeah, trying to get you guys motivated to complete your idea surveys. We are currently at 49%. So I said if we get the class to 80, I'll drop an extra quiz grade. So we got to get to 80. So keep on. They're technically not, you guys technically have, I think, to like the 13th or 14th, but I have to get grades in by like the 10th or 11th. So I'm going to put in a deadline of Saturday, May 8th in there. So we get to 80% by the 8th, I'll drop an extra quiz. So we're getting there. Just for comparison, we only had 25% total for Organic 1. 9 people. So you can ask me questions about the final exam. I mean, I can't tell you answers or anything, but you know, if you're kind of curious about the multiple choice aspect of it, or you know, anything. How many questions? Good question. It is 70 multiple choice questions. You will have 2 hours to complete it. How do they do mechanisms? Good question. Oh, hit myself in the eye with my mouse. So like on mechanisms, they might say like, they might have a mechanism. They might have a missing fishhook arrow, and they might ask you which reagent, you know, which of these reagents should lose the pair of electrons or something like that. Or they might have like 4 pictures of a mechanistic step, structure and arrow, ask you which one's the right one, something like that. It's a double-edged sword. It's good for you guys in the fact that maybe it's less stressful in a way. You don't have to start from scratch on stuff. The bad news is it's not any partial credit, so you either get it right or you don't. So, fun fact, you guys were much improved on the synthesis this time. In fact, I think collectively, you guys probably did better on the synthesis than the rest of the test, which is unusual, but you know. Only had 2.
No, like I meant
reactions. Predict the product. Yeah, there are a lot of those. Nature of the beast. Yeah. What's that? Yes, I will. I will not hand them back today because I have to give one more makeup test today. So since I won't see you again, you'll need, if you want your exam 3, you'll have to come by and get it. But I'll have them there after today. They'll be available, so be sure to come on by and grab it. Yeah. Yeah. There'll be stuff about HNMR. Yes, there are, I think, 4 or 5 spectroscopy questions that collectively talk about NMR and IR. Oh, that reminds me, something I never got. There's one more new thing I need to teach you real quick. You're going, but it's something you need because it is like, this is actually on 1 or 2 of the questions. I never went over carbon-13 NMR. Let me tell you about carbon-13 NMR. It is super duper simple, much simpler than proton NMR. Proton NMR tells you information about the types of hydrogen. What do you think carbon-13 tells you about? Types of carbon, yeah. So, if you remember, there were 4 different aspects we looked at with proton NMR. One of them was the number of unique hydrogens, right? Well, same thing here. The number of signals corresponds to the number of unique carbons. We also looked at chemical shift. We look at that in NMR as well. The same rules apply that we learned before. The same rules regarding shielding and deshielding and being downfield or upfield, they're exactly the same. Now there is a separate like correlations table for this, but the patterns are the same. There are no integrations. However, and there's no splitting. Everything's a single. So again, a double-edged sword. It's a lot easier to read than a proton NMR, but it doesn't give you as much information. I find carbon-13 NMR, its best use as sort of a double checker. So like you're trying to put together a structure. If you put together a structure, you can use carbon-13 as sort of a way to double check that to see if it makes sense or not. So for example, let's say you have something like that. Let's say you have a ketone. How many different types of carbons do you see in that structure? Oh, we're going back to the little things. Yes, it is 5. Yeah, you have 5 different types of carbon. Here, 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 here. All right. So you have your NMR. Now the scale is a lot different, or is a bit different here. It doesn't go from like 0 to 12. It goes to 0 to, gosh, I can't remember. At least a couple hundred, I think. Let me double check. Google it real quick. I wish we had carbon-13 capabilities on our NMR. We do not. That's okay. Yep, about 200 or so. We'll just say 240. So the chemical shift numbers are a little bit different, but again, the same exact rules apply to relative spaces or relative positioning that we saw previously with H&O. Like on this one, which one do you think would be furthest downfield? Just based off of what you've learned with hydrogen NMR. B, right? Not only is it bonded directly to an oxygen, very electronegative, but it's also part of a double bond, right? And you'd be correct. Signal B would definitely be furthest downfield by probably quite a bit. Next would be A and C. I'm not sure exactly what order they'd be in. They'd be pretty close. And then D, and then E. Okay, so really carbon-13 is very, very simple, at least this form of it. There are different types of carbon-13 NMRs. Some of them are a little bit more complex than this, but for the one that's most commonly used, the one that you need to know, that's really all there is to it. Right. But yeah, to answer your question about spectroscopy, there are a few spectroscopy questions. I'll go ahead and tell you, you can't have a correlations table here. So everything, you do have to remember some of the important stuff. So to give you a heads up, and I'm glad I don't have the test in front of me, so I can't have unconscious bias trying to tell me to tell you which signals to remember. But if you're looking at like IR spectroscopy, just remember some of the basics, the important basics. Your CH stretches, all of your CH stretches, those are important. Your OH stretch, that's going to be important. Carbonyl stretch, which is C double bond O. Carbon-oxygen single bond stretch. And your OOP bands. I'd say if you've got those, then you should be pretty, if you can remember those, then you should be pretty well prepared. With NMR, again, just remember the general trends, right, about, you know, what's going to be, what makes stuff go further downfield. I would definitely remember that aromatic rings tend to be between 6.5 and 8. I would remember that aldehydes tend to be about 9 to 10 or so. And I would remember that carboxylic acids are usually around probably 12, give or take a unit or two. Honestly, the spectroscopy questions on this test, I've looked at them before. They're very basic. I mean, you guys have worked more complicated ones than this, but you're having to do it, you know, without a safety net of resources, so that makes it a little bit different. Above all, let me encourage you just to take your time on this. Just like, and this is with any test, but you have 2 hours. You know, I've given these exams before, and people have turned it in like in 30 minutes, and you know, I can tell that. You know, you're just kind of weary and just kind of like, oh God, I have no idea what this is. I'll just take a guess. Really apply strategy to it. I mean, multiple choice strategy that you've used in other classes applies here as well. Go through, find the ones that you can answer right away. There are some in there that should be just like that, right? Answer those. Skip the ones that you think are going to require more thought. Come back to them, right? Use the practice of eliminating obvious incorrect answers. Instead of trying to guess out of 4 answers, guess out of 2. Have some scratch paper there. Even though you don't have to give me mechanisms, working these mechanisms on your own, on your paper, can help give you the answer, all right? So take advantage of the time given. Don't worry about trying to keep track of how many you've missed or some. You're probably going to miss some. It's the standardized ACS test. So get as many as you can. And I do have a rather generous curving system. But if you totally dog it, you know, you're still going to do bad. Like you get 10 right out of 70, that's probably not going to correspond to a very good grade. So work those practice multiple choice questions I gave you. That'll be helpful too. I don't remember what the national average is, honestly. I have it on a piece of paper. I'd have to go look. But it's pretty close, it's somewhere in the ballpark, maybe slightly over 50%, I think is the national average. 50% correct out of 70. The student that's done best in the 5 or 6 times I've given it made a 67 out of 70. They missed 3. That was a part of a really strong class. They scored in a 99th national percentile. So that year I had I think 3 students over the 90th percentile nationally, and then like 2 or 3 more over in the 80s. So that was a bit of an abnormally good year. I've had people score in the worst percentile before too. So I mean, I've also had, it's kind of funny. I've also had people who kind of struggled throughout the class do much better on this one. So again, maybe some people, just work better with that style. I've had people who did really well, kind of on other tests, kind of struggle on this one. So it's kind of a, yeah, it's kind of a crapshoot there. So just bottom line, do your best preparations and come in ready to think and work, and chips fall where they may. I can't tell you. Can't tell you that. That is private information. What did you? Did I say? I didn't say it was last year. I can tell you it wasn't last year because I didn't give the exam last year because of COVID. So it was a different year. I don't have any other information at liberty to disclose. I cannot tell you any yeses or nos about any people. Let you guess. You can call and ask all of your friends from previous years. You can ask them what their scores were. If they want to tell you, then that's up to them. Everybody's going to be fine.
Like, how much information do you want on
What? Okay, so we have a different question. So on the, we have a question about the spectroscopy problems I assigned you. What type of information do I want in the rationale? So give me a proposed structure. You can, what you probably should do is like circle the hydrogens and just like label them with like A, B, C, or D, or whatever. That's probably the easiest thing to do. And you can say, well, A gives a clear triplet on the spectrum, and it is caused by a set of 3 hydrogens, which we can see here. This set of hydrogens is split by the 2 in signal B, so this makes sense. Something like that. So just sort of explaining, you can give me some bullet points if you want to on the things that in your head made it make sense.
Well, that's the problem.
I was about to say, I thought you were about to say that's the problem. It makes no sense.
Oh no, it's just like
Trying to communicate it. Just do the best you can. Really, what I'm looking for is that you're giving an honest effort here, and that you're not just copying like somebody else's answers or something.
Well, that's what it looks like.
just give me like a little set of bulleted points that helped you get there. Yeah, that's fine.
We're at 7:45 on Friday.
7:45 a.m. Friday. Yeah, that's what we have been assigned. Not my choice. We are encouraged not to do that if possible. Because other people use this room after us too. What, kick everybody out that's already in here? Yeah. Well, I guess nobody would be in here yet, but they would be on their way.
Are you pushing 47?
Yeah, I don't plan to do it today. I had just thought of something I wanted to tell you, but I forgot what it was. I hope it wasn't important. Oh. Let's see, what else? Oh, just while I got you here, just a reminder, if you still have missing lab reports or anything, or if you have quizzes that you missed for a legitimate reason you need to make up, need to get those done as soon as possible, so I can fill in any holes. Yeah, Josh.
We should have 4 lab reports.
Narrative style lab reports. We have Diels-Alder. We have the oxidation of cyclohexanol. We have preparation of cyclohexene. And we have free radical bromination. So I think you got 4 narrative ones. And then you have the NMR problems, or the spectroscopy problems. Yeah, that's one. Yep. Yep. Cis-norbornene 5,6-endo-dicarboxylic anhydride. Yep.
A lot of copies. I wrote it up.
You have any missing homeworks in the past that you've kind of procrastinated on, definitely get those done. That'll be updated. What's that? That would be today or tomorrow. Get them to me before, if you get them to me by Saturday, that'll be fun. What's that?
Don't you have the new science happening?
Yeah, well, I don't know. I'll see. I might just give you practice problems, but I don't know. I'll put something up today, whether it's practice or a new assignment. Just 2 really hard extra credit practice problems. Is that your suggestion, Matt? I will take that under advisement. I love suggestions. Sometimes I actually go with them. Sometimes I don't. Hold on, we got a question. What's that?
Are we already getting one quiz drop or is that?
Yes, I drop 1 quiz every semester, standard. If you fill out, if you guys get to 80%, I'll drop another one. Yes, you see, professors are getting desperate for people to actually fill these things out, so this is what we have to resort to. I walked by somebody, I walked by another class the other day and I heard them saying like, yeah, if we get to so-and-so %, I'll give you 5 extra points on your grade or your test or something. I don't know what it was, but I was like, yep. I mean, I get it, you know, if I get a request in my email to complete a survey, I usually don't even open the email, so I get it. It's just like another thing to do, but you know, it's used for stuff, important stuff. So
These don't only take like 4 to 5 minutes.
yeah, they're not bad. Unless unless you like you're feeling particularly hateful, and you get to the written portion, you just want to unload on me, then it might take longer. So the best written comment I ever gotten on an evaluation was something like this. He has the voice, his voice is like that of a siren, luring sailors to their impending doom, or something like that. Like, that's kind of cool. Anything else you guys want to ask about?
I
Yeah.
don't know if I already asked this, but what are the specific topics that it's gonna cover?
Oh, the exam?
Yeah.
Organic chemistry. It covers pretty much everything we've talked about all year. Yeah.
Do you teach to the standardized test? Because I know like some classes, right? Like,
Do I teach to the standardized test? Good question. No, I don't. But it coincides very closely, so it works out well. But no, I don't teach to a specific test. I teach very much according to the book I use, because I love the book. I love the way it's organized. Just wish I could get further in it. I always seem to stall out at chapter 22. There's like 3 more chapters that would be awesome to do.
oh, we'll be tomorrow.
I'm sure you will, Matt. I know. Yep. 23, 24, 25. Yeah, there you go. There's your summer reading. What's that? Oh, you've already read ahead. Grace, yes. Shh. What's that? I'll do my best to prepare you one. Yeah, I can do that. You may not be, it may just say study organic chemistry, because like I said, it's pretty much most, but I'll see if I can, I'll look through and see if there's any guidelines I can give you that can help you. Like it will cover some stuff from Organic 1 that's specific. So like, for example, I think there's 1 Newman projection formula question on it. There's like, it was the one with the wheel, like with a dot and a circle. There's like one or two questions. I'm trying to tell you stuff, yeah. There's like one or two questions that deal specifically with chair confirmations. A lot of the stuff from Organic 1 is stuff you should probably already know and that you use all the time anyway, like, you know, asking you what is the hybridization of this atom, right? You guys should know that by now, right? You might have a question there asking you about a resonance structure. That's something that we've been using, you know, the whole time. I know there's at least a question or two about the acidity factors from Organic 1. Remember, element effect, resonance effect, all that stuff. And again, you've actually been using that still in Organic 2. But yeah, I'll put together a study guide. Would you guys like an additional review session outside of class?
I know Alex is planning on doing one.
When is Alex doing one?
I don't know.
Okay.
She told me she's planning on doing one.
Okay.
I'm doing one tonight, probably.
Oh, here she is. Hey, Alex. You're doing one tonight?
Yay. Yeah.
Alex is doing one tonight. Oh, Alex sent a chat question too, I see. Are they getting a sheet of paper for the final like they got for synthesis? No sheet of paper for this one, I'm sorry. Sorry, yeah. Yeah. I'm looking at my availability. I can be available for an outside of the class study session, I think Tuesday night. Wednesday's bad. Maybe Thursday, the night before, if you wanted one, but definitely Tuesday. So what time would work well for you guys? Would like 6 o'clock work, or maybe 6:30 or 7? Any preferences in there? I'm not starting any later than that.
Whoever's in the sport right now.
Yeah, whoever the athletes are. Any preferences? Does practice run into?
Wait, what time did you say?
Like Tuesday evening, 6:30, 7, something like that. 7? Okay, I can do that. I can do an additional review session tomorrow night at 7 p.m. So I'll try to remember to send that out through email, but put it on your calendars as well. And if you have bring any questions that you might have. Because honestly, I don't really have any additional new stuff to give you, I don't think. Yeah, Tori. All right, shh. Tori, what's that? Tori's asking a question. What's that? Yeah. So my TAs, Alex and Skylar, have been keeping track of attendance, so they'll give me a tally, and I will. You get 1/10 of a point for each session you went to. For your overall grade. Yeah. I was really trying to motivate people to go, so I figured that would be pretty good. Yeah. Bring me something, Eli? Oh, Lisa. The good. I don't want anything. It's the end of the semester. My brain is mush, so I don't think I can answer any questions.
Do you know
The answers for your assignment? Yes. Yes. I can do that. Let's do that after we're done with everything else, though. My eyes aren't good enough to see that far. All right. Any other questions you guys would like to ask me about before we wrap things up today? All right. Well, if y'all think of something, just let me know. Either email it to me or come by or save it for review session tomorrow night. All right. I am done. So it has been a pleasure. I'm going to tell you, it's been a pleasure to get to know you guys this semester. I know COVID made last semester kind of crazy, so it's pretty cool getting to actually know you and work with you. So good luck on your final and all your other finals as well. Yeah, I hope you tank all of your other ones. Just do good on the